Good evening, everybody. Welcome to the session on how DTCC achieves resiliency with AWS and Snowflake. This is a business continuity session, and we'll be going into the details of business continuity, replication, and disaster recovery. Co-presenting with me today is Sudha Gullapalli, and I'm Arjun Puri. We are both part of the data engineering team at DTCC. So DTCC, who are we? DTCC is the premier post-trade market infrastructure for the global financial industry. From operating facilities and data centers around the world, through its subsidiaries, we automate and centralize and standardize the processing of financial transactions across the trade lifecycle and mitigate risks for thousands of institutions worldwide. We're a systemically important financial market utility, SIFMU for short. There are 8 SIFMUs in the United States. DTCC subsidiaries are 3 of them. SIFMUs are enacted by Congress and governed by the Federal Reserve, the CFTC, and the SEC. What a SIFMU means is that the disruption or failure of a SIFMU would destabilize the financial markets of the United States. So therefore, there's a heightened pressure on us to make sure that we are always performing with respect to availability, resiliency, financial risk management, as well as liquidity management. So DTCC is committed to maximizing the value for our clients by delivering the world's most efficient and resilient post-trade market infrastructure with a focus on superior execution and management, as well as risk management and innovation. So some key statistics here: 2.37 quadrillion in securities processed in the year 2021. On the fixed income clearing side, we processed over 4.5 trillion in transactions each year. We're the world's largest depository, and we process 1.35 million security transactions worth 87 trillion a year. You get the message. The reason why we put these mind-boggling numbers out there was not to shock and awe you, but to remind you that each of these creates data and transactions in our analytical systems on Snowflake, on AWS. And therefore, there are some key tenets of our IT strategy that are internalized by everybody at DTCC, and especially the technology folks. So these are security, resiliency, and stability. So everybody at DTCC strives and internalizes these key parts of our IT strategy and make it very important for us to be able to execute every day. Now, throughout our history, we are coming up for 50 years next year, we've experienced a number of small and large disasters. Everything from 9/11 to Hurricane Sandy to COVID. Each of these taught us lessons and made us better at how we respond to these events. Hurricane Sandy actually, in a way, prepared us to react to COVID the way we did. We knew how to operate remotely and independently. The other aspect of this is that, in terms of resiliency, we are guided by resiliency principles, which are steeped in chaos principles that you've seen Netflix and others be a proponent of. But really, as we modernize our applications, we introduce new failure modes, both internally and externally, that we have to account for in terms of security, from a networking perspective, as well as interconnected risk. When we design for resiliency capabilities, one of the things as we modernize our applications and systems, we apply chaos testing techniques where possible or where it makes sense, and bake that into the design up front. These principles really imply that we're able to reduce the dependency on infrastructure from a software perspective. From a regional capability perspective, we build highly available systems in the context of a region, which means we have redundant storage, network, compute capabilities in the context of a region. In the context of out-of-region capabilities, we make sure that we can meet and attain our RTO and RPO objectives, and we continuously test these and improve these as we go on. With respect to operational capabilities and our resiliency principles, some of the factors that we look at is for the application to be able to maintain a state of its health with deep observability, as well as with capabilities such as balance and controls, as well as replay capabilities. One of the key aspects of our design is always trying to achieve an RTO of 0. That's only possible through a well-architected framework, as well as relying on the application to be able to pick up if there was something in transit that was not committed to a database or was not applied in the context of a region when failure occurs. So what do you mean by business continuity? When planning for business continuity involves 3 broad steps. First, you need to identify the applications that are critical to your business that you want to protect, and what does that protection look like for each of them. You want to do a business impact analysis, and to make sure that identify what the business requirements are and what cost parameters that you want to work with. And finally, you want to set objectives around recovery point and recovery time objectives for each of those applications and develop a plan to achieve them. Now, with respect to recovery point, it's the maximum amount of data loss that you're willing to tolerate. So if you look at that on our timeline, recovery point comes prior to the point of disaster. So if disaster strikes, the data loss is between the recovery point and disaster. The recovery time objective is the maximum allowable downtime your application can tolerate. So in our timeline here, the recovery time follows post-disaster during that downtime. And of course, our objective is to minimize the RTO and RPO, and we strive for an RTO RPO of 0 and a minimal recovery time. Before we get any further, maybe this should have come sooner. Not sure how many people are familiar with Snowflake, but just at a very high level, Snowflake is a cloud data platform built on the cloud, and it is meant for analytical as well as hybrid workloads and supports structured, semi-structured, and unstructured data types. It separates compute from storage, and Snowflake takes care of the care and feeding of the environments, so therefore, they're responsible for the infrastructure, for security, for maintenance and operations, while we, the customer, can focus on delivering value for the business and not spending time on trying to care and maintain an environment. Now let's take a look at some of the Snowflake's architecture and some of the failure modes that can introduce. When you store data at the storage layer, when you write data to Snowflake, data is written in columnar compressed format on cloud object stores, such as Amazon S3. When you process queries, they are processed in compute clusters, independent compute clusters, which are also backed by cloud compute services such as Amazon EC2. As far as the cloud services, which is the brain of Snowflake, which is a collection of services that coordinates activities around Snowflake. Snowflake uses cloud compute services with managed disk, such as EBS. Now let's take a look at some of the failure modes that you can encounter. The first one is a customer error. Now, a customer might accidentally delete data or corrupt data, and the next set of failures are infrastructure failures, all the way from that could range from a virtual machine failing to a zone failure, all the way to multiple regions or the entire cloud provider going down. So as you look at some of these these failure modes, there are certain features that Snowflake has that protect us or allow us to recover from these. As with respect to customer errors, such as if a customer accidentally deletes data or corrupts data, there are various capabilities in Snowflake to recover from that. First, there's time travel, which allows you to query data as of up till the past 90 days. And it lets you recover deleted data with undrop commands like undrop database, undrop schema, undrop table. There's also failsafe, which is an additional 7 days past the retention period for time travel. And then Snowflake has additional capabilities that we didn't list here, such as zero-copy clones, which would allow you to do point-in-time recovery. Now, as far as instance failures is concerned, Snowflake has built-in redundancy. Snowflake automatically replaces and reboots the faulty VMs and retries portion of your failed query. So in this case, there's no impact to us. The systems operate as normal. As far as the availability zone failures is concerned, Snowflake has built-in redundancy and operates across multiple AZs in the context of a region. As far as a complete region failure, which is a focus of our discussion that my partner Sudha will be talking about later in more detail, Snowflake has capabilities for cross-region replication and cross-region failover, which we'll be going through in great detail. And we'll leave you with a blueprint of how to implement something like that in your own environments. And of course, for entire cloud provider failures, Snowflake offers cross-cloud replication and cross-cloud failover. Some key stats at DTCC. We've been live since June 2020. Our environments were up and available prior to that. Over the course of the time, we've replicated over 42 petabytes across regions. We have multiple applications and lines of businesses at this point in production, over 400 service accounts, 400 users, 1,800 roles, 300 plus virtual warehouse or compute nodes, and 700,000 queries per day. Also, which is very important, is we participated in about 15 disaster recovery exercises this year. Before we go any further, I'd like to take a minute to recognize the fantastic foundation that Snowflake has laid for us, or Amazon has laid for us, that allows software like Snowflake to evolve and develop. On our side, I should have done a better job of this, but this is one of our analytical applications that we had in production some time back. Some of the key things that I'd like to call out is the first and foremost, we've created a virtual data center between our on-prem environment, our VPC, and Snowflake using Direct Connect, AWS Private Link, security groups, and trust relationships that we build between us and Snowflake. We also use customer managed keys for all our cloud applications or SaaS applications, which are steeped in KMS, HSM, IAM policies and roles. We use EC2s, S3, of course, CloudWatch, CloudTrail, but also SageMaker, Wrangler, and we use Python, Spark, and Amazon EMR. So with that, I'd like to invite Sudha to walk us through a little more detailed playbook for replication and DR.
Thank you, Arjun, for that great overview. Thank you all for attending our session today. I'd like to now walk you through how we implemented resiliency using Snowflake and AWS. In an effort to modernize and mature our resiliency and business continuity program within our organization, operational rotation of our application has become our key goals for now and future. What this means is that our applications need to rotate between the two regions periodically. Our mission is to give our application teams turnkey business continuity to address the most critical catastrophic failure scenarios and to come out with near zero data loss and instant recovery time. So with that mission, we started our journey using Snowflake native features like database replication, which allows you to replicate and failover your database objects and databases. And then account replication feature allows you to replicate and failover your account level objects, such as users, roles, warehouses, etc. There's a pipeline replication feature that allows you to replicate and failover your data pipelines and its objects. Lastly, there's a client redirect feature, which allows you to seamlessly failover all your client connections. So just wanted to mention account replication feature and client redirect are two new features that were introduced by Snowflake this year. And then pipeline replication feature is coming up soon, sometime next year. Here, I'd like to walk you through the disaster recovery flow between our two regions. You have the primary in this example. East is your primary, west is your secondary. So you first need to enable your replication features for both the accounts. You enable the account replication, and you enable the database level replication. And you set the replication direction from east to west. So the data, all the objects get replicated from the east to the west, west being the secondary. When an outage occurs, you fail over to the west account, make the west the primary, and you change the replication direction from west to east, provided your east is up and running. And then when you're ready to fall back, you simply fall back to your original primary and again change the direction from east to west. If you notice on the regional box, you have to the left-hand side of the box are all your account level objects. To the bottom, the storage integration is a pipeline object that's not being replicated today because the pipeline replication feature is not there yet. To the right of the box are all your database level objects. And if you notice the bottom four objects, they're also pipeline objects, and they're not being replicated today. And Snowflake account can have one or more databases as well. So failover group. This is the first class Snowflake object where you specify what you want to replicate, where you want to replicate, and when you want to replicate. You see how Snowflake, it's easy, simple, quick, and painless to implement. You see how Snowflake has made a complex process such as replication into one simplified solution. These failover groups gives you flexibility to segregate your failovers, like either segregate them by all your account level objects to failover separately, and then you failover your databases by line of business or based on your application criticality. And Snowflake also uses incremental refreshes between incremental questions. We'll get to them at the end. Snowflake also uses incremental refresh to refresh the data and objects to the secondary. This is very cost-effective and efficient. Prior to account-level replication, within our organization, we had a custom process to replicate these objects. So we did a full sync of these objects to our secondary account. So for some of our larger accounts, this process took anywhere between 40 minutes to 60 minutes. And this was scheduled at once a day or twice a day, so our data is not as near real time. So you see how much credits were burnt. So with this incremental refresh, our data and objects are more near real time. This feature is supported by Business Critical Edition of Snowflake. Pipeline replication allows you to replicate all your pipeline objects, and this feature is coming up soon, such as external stages, storage integrations, pipes, stages, and tasks. Snowflake ensures that we have idempotent data loads after a failover. So when Snowflake has a copy into command, or when you use a Snowpipe, behind the scenes, what it's doing is it's reading from an external stage, which is our DTCC S3 bucket, and loading it into a target table. So Snowflake tracks all the metadata of the files that it has processed in a copy history view. This data will also be replicated to the secondary account. With this, when we fail over, we can replay the missed data files and rest assured that we don't have any duplication of data. So it's built into the copy into command. So client redirect feature, every account can have hundreds of connections. It could be from your CI/CD pipelines, it could be from your IDP data providers, as well as it could be from your visualization tools, your ETL tools, your web applications. So all these connections need to seamlessly fail over. So with this client redirect feature, what we do behind the scene is there is a connection object which has a global URL. That's the global URL that all the applications should be using. So when the connection fails over, we are actually redirecting the call to the West account. This feature is supported by all client types, such as NoSQL, Python, JDBC, ODBC, etc. What happens is when we fail over to the West account, Snowflake does the DNS name change and redirects the global URL to the West account. This redirection takes anywhere between 30 to 45 seconds. For customers such as DTCC, where we use private link connectivity, we also need to make a CNAME change to point to the VPC endpoint on our end. That is the West one. So this feature also requires business critical addition of Snowflake. So here I'd like to walk you through the different authentication methods that we use. For our service account or our functional users, we use a standard password policies within our organization. For privileged users access, we also, in addition to the password policies, we also enable multi-factor authentication for additional security. Lastly, for single sign-on users or individual users, we provision them through our identity provider, which is Microsoft Azure AD. How that works is, from our on-prem AD domain, all the AD groups are synchronized into the IDP provider periodically. And first, you need to enable or register the Snowflake global URL or Snowflake accounts global URL as an enterprise application in your IDP provider. Then you also register the security token from the SAML security integration from Snowflake. And this is the token that the IDP provider uses to connect to Snowflake. And lastly, you have to enable the AD groups that you want to provision to this account. Once that's enabled, SCIM will provision the users and roles to your primary account, in this example, the Snowflake account A. And our account replication feature replicates the security integration, our users, our roles, to the secondary account periodically. And when we fail over to the account B, our CNAME will now, our global URL will now point to the new primary, which is the account B, and SCIM will start to seamlessly provision your users and roles to the new account, the new primary. Here, I'd like to walk you through how our data pipelines are set up using S3. From source server source server, once the file is extracted, it's dual written to both east and west bucket. This is to avoid any replication lags that we may incur. And then there is this pipe object, which reads from the external stage, which is the S3 bucket, and loads it to the target table. This pipe is always in pause state on the secondary, and it's running state on the primary. And then that external stage, the S3 bucket, has to have a trust relationship in Snowflake. Once that's established, it can read from that S3 directly. Snowflake ensures that, notifies the pipe that the file is ready to be processed via the SQS queue. Once the queue notifies the pipe, it reads from the stage and ingests into the target table. Then the data is replicated to the west account. When a failover happens, today without the replication feature, we just have to recreate the pipe on the west to make sure it's synced up to match the east. And we resume the pipe on the west, the new primary. And your application teams have to reconcile and replay the missed data loads today. Once they do that, the regular ingestion process takes place for any new files that come after. We also use private link connectivity from our on-cloud and on-prem servers. So from on-prem server, we connect using AWS Direct Connect to our DTCC private endpoint. So that server needs to have firewall rule open, and that security group inbound rule needs to be created around that VPC endpoint security group. Also, our DTCC endpoint will have a trust relationship to talk to Snowflake endpoint to connect. And that is established when you enable private link feature for Snowflake account. So also, Snowflake has two stages, external stage and internal stage. External stage is external to Snowflake, so the S3 bucket resides on our DTCC account. Internal stage in an S3 bucket that resides on the Snowflake AWS account. For all external stages, we connect via VPC using private endpoints as well. For internal stages, when you put a file to internal stage, or when you are fetching large result set, we need to have access to Snowflake S3 bucket. And we have that access through our Squid proxy. We need to whitelist our source server IP as well as the Snowflake S3 URL on the Squid to connect over the internet. So this is how we have configured our private link connectivity. Here, I'd like to walk you through how we model our failover groups. To the left, on the top, there's an account-level failover group, which only replicates all the account-level objects except for databases. And each account-level failover group has a global URL. In this example, it's DTCC risk QF private link snowflakecomputing.com. That is the URL that you would register in your IDP provider to provision your users and roles. And then each account can have one or more database level failover groups. So these database level failover groups are basically if you want to segregate your application by line of business. In this example, finance app is failing over both their databases together. And it has its own global URL for finance QF private link snowflakecomputing.com. So when the application is ready to fail over, it fails over not only the failover group, but also the connection, that global URL it fails over. And additionally, since it's a private link, we have to make a CNAME change. With this model, our applications can rotate independently without impacting one another. For all the non-replicated objects, like I said, we have a custom process that synchronizes these into the DR side. We also have governance around it, like a reconciliation process to just make sure the objects are in sync between our primary and secondary account. So this is just to ensure that we're not missing any missed objects. So like I said, this slide is just to say that you can configure your failover group by line of business or by your application needs. So it gives you that flexibility. And each failover group refresh interval can be scheduled at different times depending on your application tier and criticality. Here it's just saying that at that point in time when the data is refreshed, the data between the primary and secondary is in sync. In this example, I just want to walk you through how the client connections get redirected. The finance app is using the finance global URL, which is now pointing to the east VPC endpoint. All your connections are now pointing to the east. When you fail over the connection, and you're changing your C name to point to the West VPC endpoint. So all the connections that use this global URL will now connect to the new primary, which is the West account. So our application teams will have to reconcile the missed data loads today. How we do it is when the file gets pushed to the S3, it's also registered in a log file and an on-prem or an on-cloud database. And the ETL will then push the data to the target table and also register it in the Snowflake account, what file got processed. These two will happen as one transaction. This data is getting replicated continuously to the West account. When a failover happens, the first thing the application teams have to do is compare the log file that's on-prem or on-cloud and compare it with the file in Snowflake and see that file 2 and file 3 are missing, and they have to replay that data. App rotation for extended runs. These are our standard DR runbook steps, and it has 2 phases, the setup phase and the recovery phase. In the setup phase, first you need to stop all your data loads or any ETL loads that are happening. You want to pause your pipes and any scheduled tasks that are running on the primary account. You also want to suspend the refresh from primary account A to the secondary B. Then you fail over to the B. You make a CNAME change to point to the account B VPC endpoint, and you reverse the DR config file saying your B is your primary and A is secondary, and this is for replication jobs. And resume your pipes and tasks, and you resume your data replication refresh from B to A. You restart your ETL loads, and you do a validation. Once that's done, your application is ready to use the new primary account B. These steps are mostly done through AutoSys, and we are looking to, right now, as I speak, we are automating these runbook steps via using a self-service portal, which is built by our CI/CD team. So on a click of a button, application will rotate to the new primary. This will drastically increase our RTO. Prior to this app rotation, we also have some accounts that do planned DR exercises. It's similar to app rotation, except that it has the third phase, which is a fallback phase. So when you're ready to fall back, you simply fall back to the original primary. This will get deprecated once the app rotation, every app is migrated using app rotation model. We also have scheduled monitoring job that runs every 15 minutes and checks for the following metrics. It checks for refresh duration, refresh lags, percentage of times it had met the SLA, and also looks for any refresh failures. Each application or SysID, depending on their tier, their thresholds are configured. If the application did not meet the threshold, the job would fail and an incident would be raised. And so somebody can look into why we missed the SLA. We also have a centralized reporting system. We collect this data from all our Snowflake accounts, and then we monitor our spend, we monitor our performance metrics, and we also monitor our replication refresh metrics, like refresh rate, average refresh rates, average lag time, average rates, bytes transferred, and credits used, or the different metrics that we monitor for. And this data can be sliced and diced by line of business, by environment, region, or by single SysID or application. We do have high availability clusters on our admin server. This is where our application jobs are run, and the code gets deployed to both East and West accounts. And like I said, all our jobs run via AutoSys. So AutoSys first checks if East server is up and redirects the call to the East server. And when if east is down, it will redirect all the calls to the west server. So with that, this is how we've achieved replication. I will now hand it over to Arjun Puri. Thank you.
Thanks. So if you take back a few things from this, I think 3 or 4 slides that Sudha presented. One, around the app rotation framework. Second, the client connection object. And the 2 process flow diagrams. That allows you to basically plug and play and go and implement replication and DR for yourselves and make it's an extremely painless process. So essentially, we have one code base deployed across all the regions that we have, that we support in North America as well as the EU. So there's one process, one Lego blocks of that process flow that becomes the runbook that we use to replicate and perform DR exercises. And speaking of that, that's extremely simple design, really elegant design, which naturally leads to a very incident-free, simple setup, inexpensive to operate. And we have centralized orchestration for replication and DR, as Sudha showed you. So that allows DevOps teams, level 1 DevOps teams to support this centrally, and it's very efficient. So really, to kind of summarize this, some of the benefits of replication and failover for DTCC. So like I said, we have consistency. There's one runbook applied everywhere, and we have a lot of accounts in a lot of regions that are deployed with replication and DR capability. It also removes any operational burden for us to manually do any unloads or try to refresh data. It's extremely elegant and simple design. With respect to speed, replication and DR is highly performant, and our average P99 lag is 97% of the time is well under 2 minutes. It's also extremely easy. I kind of mentioned the process flow is plug and play Lego blocks. When we onboard any application, it's essentially a 2 or 3 day effort for us to take somebody, onboard them, help an application to set up their runbook, do a couple of DR exercises, take them through the permit to operate DR test, and off they go. In terms of savings, replication, Snowflake's replication is a very inexpensive service. Essentially, you're paying for storage in outer region. There is the data transfer costs are minimal, and so it's a very inexpensive service that, in our opinion. It's also very cost effective for us because we have one way of doing this across the spectrum of our implementations, and it's also in terms of savings. There's there's no manual task for us to manage or do or unload data or rely on S3 replication or what have you. And then finally, Snowflake is a very customer-centric company. They're constantly engaging with us to get our feedback as they make improvements in the realm of less business continuity. I mean, across the board, but like the business continuity. So we get to participate in and provide feedback as they're developing the features or improving the roadmap further along, going into the next year. But also, we get to partake in some of the preview features in our non-production environments that we use today. So really, now that you've seen our process flow and process in action, some key takeaways to think about is to plan, make sure that you understand your company's assets and all the various types of disasters, and put your plan to test. Make sure you poke holes in those tests and look for edge cases. Automate. The only way we could have done this across the number of accounts that we have at the scale that we have was through automation. All the DR exercises that we talked about this year, the 15 or so, they're supported by level 1 teams. Typically the engineering team doesn't show up for those. So really it's extremely simple to set up. One setup with automation, you can really achieve that level of sophistication. And then of course, keep measuring, create a benchmark, look for opportunities to further improve that via automation or various processes. And your next benchmark your benchmark then becomes the next benchmark for the next process improvement. So keep that feedback cycle going.